Hi, I'm Adrito, a PhD researcher, and currently my work is in machine learning applied to surgical step recognition in endoscopic transsphenoidal pituitary surgery. Breaking that into the component parts, the pituitary gland is a pea-sized gland just off the base of the brain, and tumours can grow in it, causing blindness and even death. Transsphenoidal surgery is a minimally invasive surgery where the surgical tools are entered through the nose to remove the tumour, and an endoscope is a very thin tube with an optical device at the end which allows the surgeon to see what's going on inside the patient and also record the surgery for later use. Surgical steps simplify an operation by splitting it down into several more manageable steps, and automated recognition of these steps can help a surgeon during training, live during surgery, and post-operatively through analysis. In our case, we have 7 steps such as entering through the nose, cutting out the tumour, and closing up any wounds. This is where my research and machine learning comes into play, or in my case, a neural network. I fed the network with several videos that were pre-recorded using the endoscope, and each of these videos has every second labelled with what step that image belongs to. And through this, the network is able to learn associations between an image and a step, and across all 50 videos that we have, it's able to make quite strong conclusions on what step an image should belong to. My best performing neural network has the backbone of a convolution neural network, and convolution neural networks in general are very good at predicting what a static image belongs to. So in our case, what step this static image belongs to. On top of this, I've applied a recurring neural network which utilizes the temporal data in the videos, i.e. the sequencing of the static images, and is able to improve on the original convolution prediction. Finally, sometimes the neural network rapidly changes its prediction from 1 second to the next, and so I've applied a smoothing function so the network is forced to predict one step and has to predict it for a sufficient period of time before it switches to another. On the dataset I've currently tested this methodology on, I've got a 73% accuracy, which is pretty decent and in line with what others have achieved in other types of surgery. And that's it, a summary of my current research. If you want more detail, an actual journal paper is linked in the description. If you enjoyed this video, a like would be appreciated, and if you want to see generally more videos of my life as a PhD student, a subscription button will be somewhere on your screen. Hopefully, I'll see you in the near future.